Cuboidal means like a cube shape, column means column. So there's different types. So simple means one layer, stratified many layers, or pseudostratified. It appears like many layers. Single layer because the nuclei are at different level. Okay.
Not all of them.
Not all of them face the surface. Okay, free surface, but they're all attached to the basement membrane. Okay, all the cells. So that's the naming. The important part about epithelial tissue is the different types. Okay, so when you look at the different types, what you need to know is the location of it, okay, and the function. So simple squamous, we find it where? Blood vessels, lungs, okay. So its function is to make exchange of these nutrients and waste efficient. That's why it's very flat, fast exchange, okay. Simple cuboidal, find it in the kidney tubules, okay. One example, or in the thyroid gland, okay. So in the thyroid gland, its function is as what? So it acts as a exocrine or endocrine? Endocrine, okay? Endocrine, alright? So make sure you know that simple cuboidal is found both in the kidney tubules and in the thyroid gland, and the functions of each, okay? So,
minimize the...
okay, so let me just minimize that. Can you see that still?
Yes.
Is it visible? Yes.
I have a question. Are we going to have the picture of slides?
Figures. There's no figures in that exam, okay? Just expect the same thing as last time.
Good.
Good? Okay. So, secretion, reabsorption of water. This happens in the kidney tubules, and in the thyroid gland, it will secrete hormones, okay? So, stratified squamous, where do you find it? Skin. In the mouth, we find it in the vagina. So the protection against abrasion, remember, very important to know this function, okay? Of stratified squamous epithelium. Okay? Protection against abrasion. Drying and infection, alright? Make sure you know that. Stratified, so lines, remember we said the stratified cuboidal? It's in the sweat glands. Sweat glands? Sweat glands, what is that? What is a sweat gland? Exocrine, okay?
Yeah.
So make sure you know that they secrete water anions. So stratified cuboidal, we find it in the sweat glands, which are exocrine glands, okay? Stratified columnar epithelium, you find it in epididymis, in mammary glands, in the larynx. So, in mammary glands, they act as exocrine glands, okay? Secretion of milk, okay? In these, in the larynx and in the epididymis as well, they secrete mucus, okay? So that's where you find stratified columnar epithelium. I think we missed one on the simple. Yeah, this slide. I think we missed this slide. Simple columnar epithelium is found in the digestive tract. So you know the slides we saw in the lab. It's simple columnar of the intestine. Between it, you find in these sort of simple columnar, you find the goblet cells. Remember, they secrete the mucus.
Yeah.
And their function, the function of this simple columnar is more of the absorbing nutrients, okay? In the digestive tract. Absorb nutrients and produce mucus. Okay? I think that's these are very simple. Location, function. So in terms of the junctions, remember we have the three different type of junctions. The tight junctions, remember, they create a waterproof barrier, okay? So liquids cannot pass through. For example, in the digestive tract, in the urinary bladder, these where you don't want the liquids to escape, the tight junctions form a very tight barrier where nothing can pass, okay? So it makes it waterproof, those organs. So digestive tract, bladder and kidney tubes, okay? Obviously in the digestive tract you have enzymes, you have that you don't want to penetrate into other tissues, okay? In the bladder you have the urine. There's lots of toxic material there. You don't want it to penetrate into other tissues, so it must be watertight, okay? And the same in the kidneys, because where the urine is formed. Once it's formed, you don't want it to escape, okay? So the tight junctions help to keep the liquid inside the lumen of these tubes or organs. Yes? Cannot go out the hollow organ. So the bladder is a hollow organ, the urine cannot escape. So it's leaking, okay? Then you have the adhesion, you find this, so this spot desmosome adhesion junction is the same name, okay? Same name for the same molecule, okay? You find this in the skin, it helps to bind the tissues but also make them more flexible, okay? So, you know, they can stretch, okay? So the skin you see can stretch because of the adhesion junctions, alright? So it's location of the skin. They're not as strong as the tight junctions, okay? Finally, we have the gap junctions. These are important in tissues like the cardiac muscle, where it allows for coordinated contraction of the heart muscle. So it's actually the protein channels of two cells fused together to form a channel between the cells, so molecules and water ions can pass through between them. Okay, so that's gap junctions. You find it in the heart, as I said, so the cardiac muscle, liver, and some in the muscle tissues as well, like smooth muscles and others. Okay. So we move on to the connective tissue, okay? We have different type of connective tissue, so I'll go through each one of them, alright? So in fibrous connective tissue, okay, make sure you know that the components, okay? The components. It has fibers, cells, and ground substance. It's very important to know that, okay? The different components. I'll go through, the different components in the other slides, okay? So you find the cellular parts of it, okay? Before we move on, the ground substance is made up of, water, polysaccharides, and proteins. So this is what gives the feature of the connective tissue, whether it's fluid connective tissue, so in plasma it's liquid, or bone, okay, where the matrix is very hard, solid. This is because of the ground substance, okay. So the ground substance gives that characteristics to the connective tissue, okay. So it can be liquid to like a range from a gel-like to almost rubbery in if you're looking at the fibrous connective tissue. So we find different type of cells in there, the fat cells, or adipocytes, remember we sometimes call them? Store fat. Fat is for insulation, okay? Or energy. So in under the skin we find fat. It keeps us warm, keeps the heat in, and protects some organs like the kidneys, okay? You find fat around the kidneys. But remember in chapter 2 we learned that the fat is important for long-term also energy storage. These mast cells these form the part of the immune system, okay? They're important in release of these chemicals called histamine, which help in the inflammatory response, okay? So basically, we're not looking into more detail of that. They release the histamine, and they are part of the immune system, alright? As well as the white blood cells, okay? So the different types, macrophage, neutrophil, lymphocyte, plasma cells, these also form part of the immune system, okay? The defense system. Then these fibroblasts are important for making the different type of fibers that we talk about, okay? So the elastic fibers, the reticular fibers, and the collagen fibers are made by the fibroblasts, okay?
Yes.
Yes.
This one, this intercellular.
If you intercellular inside the cell, okay? Sorry.
Extra. Vitellus introduction extra.
Yes.
Yeah, it's extra, not enter. Extracellular, outside of the cell, alright? The ground substance is outside of the cell. Yeah. I don't know why they put it intercellular. I didn't make the PowerPoints, okay? Somebody else did. But it should be extracellular, okay? Or, if you say between the cells, it's called intra. Maybe they meant intracellular. Between the cells, okay? The word intracellular means between the cells, okay? Between the cells. Between the cells, okay?
The perfect center.
Intra means between. Okay? I think this is just a mistake. It's also, you can also refer to it as extracellular because it's outside of the cell, or intracellular between the cells, okay? Same meaning. Intercellular means inside. Okay? It's intra, not enter. Okay, so the different cells. Then the three fibers, okay? So the collagen fibers are the stronger fibers, they're made from collagen, okay? You find these thicker fibers. We find that a lot in what type of connective tissue? Fibrous one, the dense one, okay? The dense one has a lot of these collagen fibers because remember what type of, give me examples of two types of dense connective tissue. Tendons, yeah, ligaments, okay? The tendons attach muscles to the bone, so they have to be very strong. So they have a lot of dense. Under the skin you find irregular dense connective tissue. We'll get to that. So these collagen fibers are important though. So elastic fibers, these yellow ones, they're more important in organs that stretch a lot, like the bladder, stomach. You find in the vocal cords, okay? Elastic connective tissue, okay? Reticular fibers, these are these branched fibers, thinner. So elastic fibers made from elastin, okay? So and collagen and reticular fibers are both made from collagen, okay? But the collagen fibers are much thicker, strong, less flexible, okay? But this one is made of collagen, okay? They have these branches, and you find it in soft organs like the liver, the tonsils, the lymphatic nodes, okay? The spleen, these sort of soft organs, they provide a network for the cells to keep the cells, okay? To support the cells. Huh? Soft like liver. Liver is a very soft organ, huh? Spleen, lymph, the lymphatic, like your tonsils, and you find lymph nodes all over your body, okay? These are soft organs. They have reticular fibers. It makes a framework for the cells, okay?
We find the elastic in liver and stomach.
Elastic in the bladder, stomach, these organs that stretch, okay? Yes. all those organs, they are soft organs, okay? Liver, spleen, and lymph nodes, okay? Alright, so let's move on to the top. So again, location and function, okay? It's very important here. The same we did with epithelial tissue. So loose areola, we find it around the internal organs like the stomach, bladder, and so on, muscles, and around blood vessels, okay? So these give like very good flexibility, but the strength is medium, not as strong as the collagen fibers, okay? So it doesn't have a lot of collagen fibers, it has more elastic fibers, okay? It gives it more flexibility, and in loose connective tissue, the fibers are not arranged in a particular pattern, okay? So they're random fibers, okay? You saw that, remember, in the lab? There's a slide on that. So that's what it is. So the fibers are random, they're not in an arranged fashion, and also they have distance between them, okay? They're not packed very dense. That's why the term loose, okay? So we call it loose areola connective tissue, alright? It provides medium strength but more flexibility, okay? Then you have the dense, as I said, you have the regular dense connective tissue, which forms the tendons and the ligaments. So they have a lot of collagen fibers. It makes it very strong, okay? So you see this? They're very packed together. That's why they call dense. And this gives it strength. You know, if you have, as I give you the example of, you have one string, you know, you pull it, it breaks. If you put like 100 of them together, you try pulling it like a rope, it gives it lots of strength. The same thing is happening here. So regular, the fibers are in a regular fashion, okay? You find it in one direction. But in irregular, you find the fibers that
are random.
Different direction, but they're still packed, they're still dense. You find this in the skin, okay? Underlying of the skin, okay? The other thing to note is that in these dense connective tissue, there is very little blood supply, okay? So it takes a longer time to heal if you damage it, okay?
Not like that.
Not like the bones, unlike the bone, okay? So tendons attach what? Muscle to bone, ligaments, bone to bone, okay? And dense irregular we find in this lower skin, okay? This is more to help protect, you know, and cushion. It's like a very protective, yes.
And tendons take time to heal?
Yeah, tendon and yeah. Overall dense connective tissue we're talking about. So we find dense irregular under the skin, okay? Elastic connective tissue has more of the elastic fibers, okay? And this gives the ability of these organs to stretch when they fill, like the bladder, and then when they empty, okay? So, and they have very strong flexibility, so without breaking they can stretch. You see the coiled structure of the fibers? So they can stretch and recoil, okay? So made of lots of elastic fibers. So we mentioned like stomach and bladder, and also in the vocal cords that produce the sound, okay? It's very important for that. The reticula, you find those in the softer organs, like we said, the liver, lymphatic system, like spleen, tonsil, and lymph nodes, okay? As you see, you can see that there's the elastic, the reticular fibers. They're branched, and in between you find the cells. So this sort of structure, this network, gives some support for the cells. Okay, there's lots of cells in these sort of tissues, so it actually allows some movement of the cells. Okay, this sort of soft organ with the reticular fibers. So once again, location and function, very important to know. So we move on to the specialized connective tissue. So in the blood, we find what we call formed elements. Okay, the formed elements are the three different type of cellular parts. We're not on to. I'm in the wrong section. We're not in blood. We're in connective. We're still in connect. Yeah, I thought this was blood. I made a mistake. All right. Cartilage, okay? So we're in cartilage. Remember, cartilage is also, they don't have many blood vessels. They heal very slowly. Make sure you know how they get the nutrients, okay? Read the book about it, alright? So it's made up of collagen fibers. We find within these regions called the leucana, chondrocytes. Those chondrocytes are derived from another cell type, stem cell type, which we call chondroblasts, okay? It has collagen fibers, made up of collagen fibers, okay? Blood vessels are missing, okay? So it heals very slowly, so it has to get the nutrients somehow. Go to the book. You find this in many parts of the body that maintain shape, like the nose, the ears. You find it between the joints and cushion it, between the vertebra. Okay, so there's different type of cartilage. We'll talk about it. So its function is more to protect, cushion, and the joint cavities. Okay, so protection and cushioning of the joints, or shape of certain parts of the body. So let's go one by one. The hyaline cartilage is the one that you find mostly in your body. Okay? So hyaline means this glassy cartilage. Okay? Made from collagen fibers. Okay? So that's why it's the white appearance. You find it at the ends between the two bones. Okay? At the ends of the long bones. Okay? You find the hyaline cartilage. You find it between the ribs, where the sternum is, okay? That the ribs meet in the middle. Also, as a developing fetus in the mother's womb, your skeletal system is not bone yet, it's cartilage, it's hyaline cartilage. And some part of that still remains is in the nose here. It hasn't, yeah. Yeah, ears, but the nose is the hyaline cartilage I'm talking about. Okay, this one is elastic cartilage.
Yeah.
Okay. Yes.
The type of cartilage of the joints is hyaline.
Yeah. Most of the cartilage is hyaline cartilage. Okay. Elastic cartilage we find in the outer ears. Okay. It has more elastic fibers. So in one location, you see only one location, elastic cartilage, okay? And the fibrocartilage also in one location. Where do we find that? Between the vertebra, okay? So in the back, between the vertebra. So you have you have your spine. Between them you find this disc. These are made from fibrocartilage. Also, there's one other location. In the knee joint, you will find some fibrocartilage as well. There's a disc there, okay?
Knee joints.
In the knee, you will find fibrocartilage. Between them is a disc. I'm not sure about that, but I know that there is fibrocartilage there.
It's not mentioned.
Not mentioned here, but it is, okay? But for you, you just need to know that it's this location, alright? And these are acting like shock absorbers. You know, when you jump up and down, it protects the spine, okay? This disc. So for cartilage, make sure you know how it gets its nutrients. For bone, we have two types of bone. Spongy, compact. Where do we find compact bone?
In the middle.
The shaft.
The shafts and on the outside of the ends. Okay? Very important to know that.
Cover the spawn.
Yeah, so it covers the shaft and the ends, okay? Compact bone. On the shafts of the long bones and on the ends of it you find compact bone.
In the end also compact.
Covering it, okay?
Cover the
The
spawn.
cover. You have inside spongy bone, okay? And the structure of the two, with the compact, remember that the ground substance here is
So,
rigid, okay, solid. It's mostly made up of calcium and phosphate, okay? And we find these cells called osteocytes in the leukocyte, okay? So if you have a look at here, these are the osteocytes. We found them in these regions called the leukocyte, and they connected to this central canal. By canaliculi, these structures, they connect to each other and to the central canal. In the central canal, you find blood vessels and nerves. That's why the bone heals very fast, because it's got blood supply. And the canaliculi help to get these nutrients from the central canal to the osteocyte. Okay? So this sort of system, these round rings of osteocytes surrounding the central canal, we call this an osteon, okay, or our version system, okay? And once again, it's very important to know that you find it in the outer shafts and covers the ends of the long bones, the location, okay? In terms of spongy bone, this is more lighter, okay? It's got these holes in it, okay? That's why it's called porous. You find it in the in the end of the long bones, okay? Inside of the long bone. You see, this is the long bone. This is the outside is compact bone here. All of this is spongy bone, okay?
Outside we find only
Compact bone, covering on the outside, but the shaft is all compact bone. There's no, and within the shaft, what do you find? Bone marrow. Remember the bone marrow. Bone marrow. So inside here, yeah, blood vessels. The blood vessels are in the central canal in the compact bone. Remember. So there is the inside here is a hollow place where you find the bone marrow. Okay.
what's the difference between yellow and red bone marrow?
Where does it say red bone?
And the spongy. Sure. Sure.
I don't see red bone.
In the spongy.
I'm not sure about the difference between those two. Okay. But in the bone marrow, you find stem cells that make the white blood cells and red blood cells. Okay, we call them the hemopoietic stem cells. You also find another type of stem cells called mesenchymal stem cells. So they give rise to the red blood cells and white blood cells. I'm not sure the difference between red and I'll find out. But it's not, don't worry about it, okay? I think we've covered the bone. Blood, now it's the blood, okay?
Yes.
So we have the formed elements in the blood, which are the cellular components. So red blood cells, remember, transport oxygen. White blood cells for defense. Sometimes they have different names. So red blood cells, RBCs or erythrocytes. White blood cells, WCs or leukocytes. So transport of oxygen, removing of CO2, defense, okay, against infection, okay, white blood cells, platelets participate in clotting, okay. So if you have a cut and you're bleeding, the platelets will form a clot and stop the bleeding. So make sure you know that these three, and the matrix of the blood is liquid. It's called plasma. We will go into more detail about this in the next semester. The components of plasma and the cardiovascular stuff. For now, we just need to know that what it is, okay? It's made up of many proteins and water and ions and so on, okay? I mentioned that the stem cells in the bone marrow give rise to all these cells, alright? The white blood cells, the platelets, and the red blood cells. So adipose tissue, I mentioned earlier, it's a form of the loose connective tissue, and it has very little ground substance, okay? Mostly lots of these fat cells with the vacuoles containing, the fat. So sometimes they're also called adipocytes because they're so filled with, when they filled with fat, what happens is that the nuclei is usually pushed to the periphery of the cell. That's how you identify them, okay? By these, the cells, the nuclei are the periphery. Sometimes students confuse these with the lung,
The alveoli.
Yeah. It's not. This is a different magnification to that, okay? That's why you can't tell the difference, alright? One other thing is that these, when you eat, they get bigger. When you diet, they shrink. The numbers don't change, okay? So we find that the function we said was protection under the skin, storage of long-term energy, surrounding some vital organs like the kidneys to protect it, okay? So it has quite a few functions. Alright, about the muscle. Yes. So, just important thing is to understand that the function, okay, which is protection of some organs, insulation, keep you warm, and also long-term storage for energy, okay. Mostly it's made up of cells called adipocytes, very little ground substance, okay.
What is mentioned?
Here. But we know another function of it from an earlier chapter. Chapter 1. What is it? Yeah. It's not mentioned here, but it's mentioned in another chapter. How are we going for time? So we'll move quickly from this chapter. The same thing with the three type of muscles, okay? We need to have understand what the fibers that make up the muscles. What sort of fibers? Actin and myosin, very important. I think it's mentioned here. Yeah.
The second one.
The fibers, make sure you know those, okay? The fibers make up the muscle, and we need to know the difference between the three type of muscles, okay? So skeletal muscle, is it voluntary or involuntary?
Voluntary.
Involuntary?
No,
Voluntary? Okay. I thought. Yeah. What type of cells we find in there? Multinucleated or single nuclear? Multinucleated, okay? Multinucleated. Long cylindrical, okay? that have this nuclei at the periphery, at the surface of the, we find striations in them, okay?
Yep.
Now, we find these striations, what are they made up of?
Actin.
Actin and myosin, okay? Actin and myosin. Don't forget that, these bands, yes.
Which one is the white and the dark?
I think the
Actin is
The dark is
actin is the dark one, I think. Yeah. We're not going to learn about the physiology of how these work, but they work by pulling each other, and that's how the muscle contracts. You will probably in next year physiology, when you do that, you will understand how they work. It's very fascinating how it works. It uses ATP to pull each other. They walk on top of each other like the proteins. They pull each other, and that's how the muscle contracts. So one major difference between these striations and the one we find in the cardiac muscle. What do we find in the cardiac muscle? We find these darker striations. Intercalated discs. Are they made from actin and myosin? No. What causes that? The gap junctions, remember? Yeah. The gap junctions. They're unicellular, okay? So the location is that they attach to skeleton via tendons, okay? For skeletal muscle and movement of body parts and head, neck, legs and all that, alright? So important to know that. Understand that it's multinucleated, it's long cylindrical, and it has these dark striations which are made from the actin and myosin, okay?
Long
The striations,
No, long.
they're long cell, cylindrical, multinucleated, okay? Now we compare this to the second type of muscle, the cardiac muscle. We find that the cardiac muscle is what? Branched, huh? It has branches. These dark striations, they're made from intercalated discs, okay? These are, if we look under the microscope and we see a cell like that, with these dark striations and branched cells, what sort of cell is that? Cardiac, okay? You see, don't forget that, okay? The appearance of it is very important. And intercalated discs are made from gap junctions. This type of muscle is involuntary, so we don't have control over the heart, okay? So it's easy. Location is the wall of the heart, you can't find it anywhere else. Pumps blood, right? The smooth muscle, we find these long cells that are pointy at the end or tapered, okay? And we don't find the striations in these ones, alright? They're single nuclei, okay? Involuntary, so we don't have control. We find it around hollow organs and blood vessels, okay? I think that covers, so it covers the smooth muscle there, alright? Smooth, yeah. Smooth muscle is single nuclei, long cells that are pointy at the end or tapered, the same word. This word tapered, it means that the cell is like this. Alright? It has a pointy end on each side, okay? Yes?
So the intercalated disc made up of gap junction?
Yes. So smooth muscle is internal organs like intestines and stomach, bladder and so on, whatever is in there, and blood vessels, okay? You find this smooth muscle around those. Yes.
What are they made of? Gap junctions?
Which ones?
The small ones.
The smooth muscle?
Yeah.
No. The gap junctions, you find it between them, okay? You find between them. Between two cells, okay? They're made up of protein fibers, okay? The actin and myosin. Alright, for the nervous tissue, we need to understand the two types of cells, okay? What is the function of a neuron? Very important to know. Huh?
Transference, not
Neurons transmit electrical impulses, okay?
also
Generate and transmit, okay? Neuroglia, what do they do?
Protection.
Support, protection,
Give nutrients.
give nutrients. Make sure you know those three functions, okay? So let's look at the nerve cell first, okay? It has three different distinct parts, okay? You have the cell body, which contains most of the cytoplasm and the nuclei, and you have this axon, okay, which is covered by this thing called myelin sheath, okay? And then you have the dendrites, okay? So these extensions. Now electrical impulses pass in one direction, okay? From the dendrite to the cell body route to the axon. It doesn't come this way, okay? So the axon, does it move electrical impulse towards the cell body or away?
Oh,
Away, okay. Now if you have some problem with this, what will happen? So if you look, if you cut this off,
not so good.
Scambas, there is a lot of charge in the cell.
yeah, it will damage. You won't be able to, like people who have a back injury, the axons get damaged, they stop walking because electrical impulses, long distance one, doesn't pass through. Don't forget. Okay? The myelin sheath. Yeah, I think we haven't mentioned that here. Yeah. But we will learn that next semester in nervous tissue. These little things. This is called the myelin sheath. Okay? But we don't need to know it. Okay?
Exon is enough.
Huh?
Exon is enough.
Alright, the glial cells. So make sure you know about the function of the nerve tissue and the different parts and how the electrical impulses pass through it and what happens if you disrupt functions. Okay? The second thing is the glial cells are important for their function is to, they do not transmit electrical impulses. Make sure you know that. Okay? Their function is to support, protect the neurons and give it nutrients, okay? The glia. So it's sometimes called glial cells or neuroglia, the same thing, okay? Nerve cell or neuron is the same thing.
So when you break one point from the axon to the cell nucleus, what happens?
Well, electrical impulses stops.
Let's stop.
Yeah. Well, it's not going to go anywhere. That's why people who have back injuries, if you have an accident, you break your spine there, depending on where, some people break it here, and they have no movement of hand, all the lower limbs. If you break it lower, then you can't walk, okay? Because the axons have been severed, they're broken.
And doctor, we cannot regenerate the...
No, nerve tissue you cannot regenerate. But there is some research now to use stem cells to do that. Inshallah, in the future, maybe they'll have some cure for that. Yes.
Just one block in the property.
Well, when it breaks, one is not going to break because it's all in one section. It's like a lot of cables coming, then they separate. Like a tube of, the spinal cord has lots of densely packed axons. The nerve. So if you break that, you're breaking the connection to everything below that part. You know what I'm saying? Because once it reaches up, everything branches off the spine. So if you breaking it from the spine, all the branches are disconnected. Huh?
It's just like restriction.
Yeah, you see that. If you break here, you've broken the axons to all of these. You're not going to have function of here. You break it here, you're going to lose function in your hand and everything here. There is people who have this, they can't move. They can only move and breathe. That's it. Yes?
Could the electrical impulse go one
Huh?
side or
The what, sorry?
electrical impulse?
Electrical impulse only travels in one direction, away from the cell body. So the location is this, the brain, the spinal cord, and the nerves. This is all nervous tissue. And it's generation and transmission of electrical impulses is the function of only one of the cells. Which one is it? The neurons. And the support and protection and nutrients is the glia or neuroglia. Okay? Don't forget that. Alright? Let's move on to the next chapter. I think that should that covered a lot of what it should be. If you know that.